Okay, now on the first problem for homework, just leaping through your homework quickly, I saw a lot of graphs that look like this, okay? And that's good. It's probably the right two graphs, but there's one more step, which is to find the sum of the two functions, the graph of the sum, okay? So let's review again what it means to draw the graph of the sum of two functions. Now, let's just say this function's x plus 3 and this function's here 1 over x minus 5. And let's go ahead and kind of color code them. So we'll just draw this one in yellow. Okay. So we want to draw the graph like this. Now let's just get a little language here. This is a linear function.
To what rate?
And this, we'll go ahead and make it all yellow, is your rational function. Typically, this is what we would get if, for example, we divided the linear function x minus 5 into some quadratic function, okay? Because as you know, if we want to add these, we just, use a common denominator. We're going to multiply this by x minus 5 over x minus 5, right? Which is going to give us a quadratic here, specifically x squared minus 2x minus 15. And then we're going to add the numerators, which is going to be 1. You're going to have, this is actually, I think, x squared minus 2x plus 14 over x minus 5. Okay? So we could have done a long division of this into this, and if I just did what I did correctly, this is what we would get, right? And you know from last time, and y'all did pretty well with the long division, that if I divide this by this, it's very plausible I get this with a remainder of 1, which means it'd be this plus 1 over x minus 5. Okay? So, what we're doing is we're constructing a graph of this function, essentially, except I didn't start you with this function. I just started with, okay, this plus this. Okay? So, but this is what you do. If we started with this, we would get this. We would draw these two graphs. And now we got to do the sum of these two functions. And that's the one thing that's missing on most, but not all, of your papers. So, what I'm going to do is I'm going to draw a few vertical lines here. Okay? And we've done something very much like this before. I don't think I actually drew the vertical lines. But for each vertical line, other than the asymptote, I'm going to draw an arrow indicating the value of y for the corresponding value of x. Because, of course, each vertical line is on one value of x, right? If this is x equals 5 out here, this is probably about 4. This is probably about 1. This might be about close to 3, 2 7/10 or something. Okay? So x has a value on each of these vertical lines, and this arrow represents the value of 1 over x minus 5 for this value of x. This arrow represents the value for this value of x. This arrow represents the value of this function for this value of x, right? We understand that? Should be pretty clear from everything that we've done, but it still might be a little fuzzy, so if it is, we're going to deal with it. And of course, then we're going to have a value over here and a value over here and a value here and the rest of the values out here are too small, and the rest of the values over here are too small to draw with a piece of blunt chalk. Okay? That one's actually too small, but I'll use it anyway. And then we'll do the same thing for the linear function. So we got these arrows representing the values of the linear function. And what do we do to get the values of the sum? We add those arrows. Okay? When we add this arrow to this arrow, well, this one goes this way, this one goes this way, right? We'll put the arrows together head to tail. So if I put this one head to tail with this one, here's the tail. Here's the head of this one, so I move the tail of this one up here, and I've got something that kind of looks like this. Okay? And that gives me the value of this function plus this function for this particular value of x, for the value of x that corresponds to this vertical line. So that gives me a point on the graph of the sum of the two functions. Of course, it represents a point on the graph. Nothing that I'm doing is overly accurate, although I've been reasonably careful to eyeball it, but it's all eyeballs, so you can't rely on it. Okay, well, if we add this one and this one, well, let's just go ahead and put the tail of this one on the head of this one. They're almost equal and opposite, so this one comes down this far, giving us a point about here. Now we're approaching the asymptote, and let me distinguish the asymptote by just using a red line, okay? To distinguish it from the other vertical lines. It was dotted, but still, these are light, that's dotted, they look so, okay. So anyhow, here, well, now we've got this one that goes head to tail with this one. So the tail of this one goes to the head of this one. We're up here. So now we're going to have a point up here. And now we've got just a little short vector to add to this one. So it's just going to be a little short vector added onto this one, giving us a point here. Now if we come over this way, well, we've got a shorter vector here that adds to this one. It's probably going to give us a point somewhere about here. And now we've got a real short vector that adds to this one. It's a little short yellow vector giving us a point about here. Okay? Now, one thing I notice is that as I move to the left here, these purple points get closer and closer to this line. Why is that?
It's taking away from it less and less.
Because what?
It's taking away from it less and less.
Yeah, well, it's because the values of this function are getting closer and closer to 0, right? So these arrows are getting shorter and shorter. As the arrows for the yellow function get shorter and shorter, we have a smaller and smaller arrow to add to the one that represents the linear function, right? Okay? So the graph is going to get closer and closer to the graph of the straight line. Now over here the same thing is going to happen. I didn't go all that far out, but you see that as I keep going out here, these values are going to quickly get close to 0, right? So these arrows are going to get shorter and shorter, and the graph is going to get shorter and shorter to the graph of the linear function. Make sense? So what's going to happen, at least from here to here, is the graph is going to pretty quickly become almost indistinguishable from the graph of the linear function as we move to the left. I kind of missed this point, but you get the idea, right? Make sense? So the graph is going to become asymptotic to the graph of the linear function. Why? Because the arrows for this yellow function are getting tiny. Okay, the values of 1 over x minus 5 as we move away from x equals 5 are going to get smaller and smaller and smaller. Which means that we're adding less and less and less to whatever the value of this function is. On this side, well, you know, from here to here, we decrease, but pretty quick we're going to have to turn around and start increasing. Because we're going to have to be very close to the graph of the linear function here, because again, the rational function, the yellow function, is going to have values that approach 0, right? That's why we get what's called a linear or a slant asymptote. Okay, a linear function asymptote, but the usual name for it is a slant asymptote. Okay? Now, as we get closer and closer to the line x equals 5, which of course is your vertical asymptote, these values start getting really big, don't they? Okay? Now, I'm not going to try to draw points. I mean, I could have a point here, we go way down, we add that to this one, well, it's going to be a little bit below the axis. But what we know is going to happen is that this has to become asymptotic to the x equals 5 line, because pretty soon these values are so much bigger than the values of your linear function, which is just this big, right, that they're going to exceed it. So the yellow vectors go down here further and further. There's no limit to how far they go. So there's no limit to how close this graph will get to the x equals 5 line, although it'll never actually reach it. Okay? Because this function is undefined when x equals 5, so this function is undefined when x equals 5. Put in x equals 5, you're dividing by 0. You can't, you know, as you get closer and closer to the point where you divide by 0, you get bigger and bigger results. We've talked about that. I hope you understood it. Meaning this function, of course, gets closer, you know, gets values that get very large in magnitude, either positive or negative. And we've talked about that. So, I don't know if I'll be able to complete this graph. I got to bend over and pick up my purple chalk. Okay? I did it and almost kept my balance. I've got orthotics inside of these shoes. They shift. It's not that I'm senile and losing my balance, but that's probably a factor too. Okay, so anyhow, extending this thing up here, going to approach a vertical asymptote there, and that's what your function is going to look like, and that's what was missing. So I want you to kind of put that back in and hand it in again so I can see that you're doing it, okay? I'm not going to penalize it too heavily. It was a pretty good effort if you just got the two of them down and did a good job of it, and just about everybody's paper looked like they did, okay? So I'm pretty happy with that much progress, but we do have to lock it out, right? Make sense? Then you understand slant asymptotes and you understand rational functions better, and you can pretty much graph any rational function. If it has a slant asymptote, you can find it. And you know that it occurs when the degree of the numerator is 1 greater than the degree of the denominator, because that means when you divide the denominator into the numerator, you're going to get an x, or a multiple, you know, a number times x. And you know that that's going to lead you to a linear function, then plus your rational function, okay? If the degree is 2 greater up here, well, you're going to be asymptotic to some quadratic function, aren't you? We're not going to worry about that, but I might toss that on a test as an extra credit, so if it makes sense to you, think about it, okay? Don't worry about it otherwise. Book doesn't talk about that. Incidentally, everybody should have a copy of the rest of the text